Alrighty, let's add some more skills to help us find limits. So we're going to use this thing called the rationalizing technique. So another way to find the limits of the sum functions is to first rationalize the numerator of the function. Again, we call this the rationalizing technique. We call it rationalizing a numerator. It means multiplying the numerator and denominator by the conjugate of the numerator. So for instance, the conjugate of the square root of x plus 4 is the square root of x minus 4. So on example 1 here, we're asked to find the limit as x approaches 0 of the square root of x plus 1 minus 1 equals x. So always, if you can, and you might be able to identify it right quick, try substitution. Because if substitution works, then use it. It's the easiest method when it works. So let's try substitution. We'll do the square root of 0 plus 1 minus 1 over 0. Well, we don't really need to go any further because we already have divided by 0. That's no good. So what we're going to do is we're going to take that numerator, the square root of x plus 1 minus 1 over x. We're going to multiply it by the conjugate of the numerator, which is the square root of x plus 1 plus 1 over, well, same thing, x square root of x plus 1 plus 1. So we're going to multiply the numerator and denominator by the same thing in order to keep the value of the function. So, putting this together, we're going to start distributing. Let me zoom in a little bit. We're going to do square root of x plus 1 times the square root of x plus 1. Well, that ends up being the square root of x plus 1 squared. In other words, just x plus 1. I'm going to kind of color code this. We're going to have the square root of x plus 1 times 1, which is going to be plus the square root of x plus 1. Moving on to the next part, negative 1 times the square root of x plus 1. That's going to give us negative square root of x plus 1. And finally, negative 1 times positive 1 is just going to give us negative 1. In our denominator, not quite as much work to do. We're going to take the x multiplied by the square root of x plus 1. So we have x times the square root of x plus 1. And then x times 1, which just gives us x. Now, in our numerator, we can cross off a lot. We end up being able to cross off where we have a plus 1 and a minus 1, so those are gone. We also have plus the square root of x plus 1 minus the square root of x plus 1. So our numerator, we're just left with just x. Denominator, we've still got x times the square root of x plus 1, and then that plus x as well. Now, we can clean this up even more, because right now, if we still plug in 0, we get 0 over 0 times 1 plus 0, just 0. That's annoying. So we have to do a little bit more factoring. So in that denominator, we really have two pieces here. We have that first piece, x times the square root of x plus 1, and x. They both have that common factor of x. So we can factor that out. So undividing it out. So we got the square root of x plus 1 when we take out an x from that first one. And then when we take it out from x, we factored out, we get just plus 1. From here, we can do a little slashing. We can cross off that x. Dang it, that's really hard to do. Cross off that x, and we're left with just 1 over the square root of x plus 1 plus 1. From here, we can plug in 0. So when we plug in 0, we end up with 1 over the square root of 0 plus 1 plus 1. Well, the square root of 0 plus 1 is just 1, so we end up with 1 over 1 plus 1, which is 1 over 2. So again, here's where we plug in 0. So in the end, we can say the limit as x approaches 0 of our original square root of x plus 1 minus 1 over just x equals 1 over 2. Now another way we can check this out is by making a table. So we can reinforce that the limit, or we can reinforce your conclusion that the limit is 1/2 by constructing a table as shown below. So we can just plug these into a graphing calculator, get numbers really close to x equals 0. So you see we got at at x equals negative 0.1, we're at 0.5132. At x equals negative 0.01, we're at 0.5013. At negative 0.001, we're at 0.5001. And then once we go a little bit to the right of 0, we have positive 0.001, which gives us 4.999. You can kind of like do a little bit of law average. It's got to be halfway in between those, so it's got to be at approximately 0.5. Now, if you look at the graph version of this, now on your graphing calculators, you won't be able to see this if you're zoomed out. It'll look like it's just one continuous line. But if you zoom in far enough on your calculator, which we demonstrated in class, and I'll see if I can demonstrate for the online as well, your calculator freaks out because it doesn't know how to graph like infinitesimally small holes in the graph. So one suggestion that I have for you when doing these on the calculator, it says approximate the table using a graphing, or approximate the limit using a graphing calculator of the limit as x approaches 0 of 1 plus x raised to the 1 over x. So first things first, let's type it into y equals. Step 2, look at your graph. If you look at your graph, you can probably approximate where it's going to be. Step 3, look at the table. Now, when you're looking at the table, one thing I would suggest is go into table settings up at the top. So go to table settings and then change your delta table. That just really means how much your x's are going to change. I'm going to change my delta table to, I don't know, either 0.1 or 0.01. That's too many letters there. TBL. Make delta table 0.01. So that way, as you're scrolling around, it's only going to go up by 1/100ths. Or you can even go more specific, 0.001. So that way you can get really close to x equals 0. Now, when you do that in the calculator, again, I'll come up with a video for this in a little bit. But when you type this into your calculator, you'll notice that it's getting really, really close to approximately 2.7182. Again, I'll show you how to do that in the graph in just a little bit.